Hello everyone, welcome back to this video series on SDTM programming with R Tidyverse for clinical SAS programmers. In this series, we will see how to implement key SDTM programming concepts using R. We will take a quick look at the SAS program for the same concept and then see in detail about the R program. Please note that the complete explanation of the SAS program for this concept is available in a separate playlist. I will leave the link for it in the description of this video. In this video, we will see how to create tests as rows from variables, so which is kind of wide to long transformation. So let us take a look at the input data that we have here. So here if you see on my screen, so there is data collected for a patient 1001 at different visits, screening day 1, day 3, and there is an unscheduled visit. Mainly the information is collected in three important variables. The one is whether this uh, the example data that we are using is related to echocardiogram. So there is this question whether the echocardiogram is performed or not. And then if it is performed, the two specific parameters that are being evaluated are collected. So one is LVEF and the second one is RVEF. The first one is called, I think, left ventricular ejection fraction, and this one is right ventricular ejection fraction, and the date when the test is performed. So we have to create rows to capture the information from these three variables. So this is kind of a regular SDTM transformation that we will use when creating findings domains in SDTM. So let us now let me zoom back in. So let us take a look at the specification for this. So here we are being given the derivation algorithm for CV-TESTCD, CVORRES, and CVORRESU, and CVStat. So the derivation for CV-TESTCD says create one record for each test collected. Populate as LVEF when creating the record for LVEF, and populate as RVEF underscore E when creating a record using RVEF, and populate as CV all when creating the record for echo yn is equal to no. So we will basically have three unique test CD values. One is CV all when the test is not performed at all. So and when the test is performed, we end up having two individual components. One is our LVEF and the second one is RVEF underscore E. And then CVORRES, we are being asked to use LVEF variable when creating the row for CVTestCD is equal to LVEF, and similarly the variable RVEF when creating the test CD for RVEF underscore E. So and then we are being asked to set the unit to percentage when the result is not null. And then for CVStat, what are we being asked to do is, so set to not done when echo yn is equal to no. So basically when neither of the test is performed, LVF or RVF is performed, so we have echo yn is equal to no. On that row we are creating a test CD called CV all. So we will have to set it as not done, CVStat as not done on that row corresponding to CV all, as it is from echo yn is equal to no. And then when echo LVEF is missing, when creating the LVEF test is null. So we also have to set to not done when echo LVEF is missing when creating LVEF test, and similarly RVEF. So let us jump into the programming. So on the left hand side of my screen we have the SAS program, and on the right hand side we have the R program. So let us take a quick look at the SAS program first and then see in detail about the R program. So here I have my SAS program. So in order to create multiple rows from a single row, we are making use of explicit output statements. So here we have an output statement here, and then an output statement here, and then an output statement here. So we are conditionally assigning the values to the required variables before we output a record. So for the what are we doing here is, so we are creating a row for CV test CD is equal to all. So as per the specification, we have to create this row when echo yn is equal to no. So we are checking whether echo yn is no, and then conditionally assigning the values based on the specification to the variables, and then outputting that record. So from the using the same record, we are checking if echo yn is yes. So when the test is performed, we'll have to create rows for LVEF and RVEF. So here we are assigning CV test CD is equal to LVEF and then checking whether the result is missing or not. If the result is missing, then we are assigning the status as not done. Otherwise, we are assigning the value of value from the LVEF variable to CVO or RES and assign the unit as percentage and then outputting that record. So when echo yn is yes, so we are basically trying to output it twice, once for LVEF and once for RVEF E. And then we are checking whether RVEF is not missing or whether it is missing. If it is missing, we are saying that the test is not done. And then if it is present, then we are assigning the value from RVEF to CVO or RES and then assigning uh, percentage to the unit variable and then outputting the record. So this is how we end up having, like when it is no, we will have one record. Otherwise, when it is yes, we will have two records created, for once for LVF and once for RVEFE. So this is as per the specification expectation. And then we are creating other common variables like CVSTRESC, CVSTRESU, and converting the character result to numeric. And then we are also creating a variable called CVDTC to store the collection date in ISO 8601 format. And in the next step, we are keeping only the required variables. And finally, we are sorting the data based on subject, test CD, and date. So let us now jump to the R program and then see in detail how this can be replicated in R. So on the left hand side, I have opened the my program, and on the right hand side, I'll open the intermediate datasets that are getting created. Looks like something is not right, so I'll try to load it. I'll pause for a moment. I have fixed the issue, and now the intermediate datasets that are getting created are loaded here. So as usual, like we will be making use of majority of the functions from tidyverse package. And here on this line of code, I am trying to run the piece of code that generates the input datasets needed for this lesson. So the code which creates the input datasets are stored in this program and it is present on my hard drive. So I am using source function to call that program. So all the code present in that program will be executed as part of this program. So and I will have all the input datasets available for me. And so this source function is equivalent to our %include statement in SAS, which can be used to run another SAS program from within current SAS program. So what are we doing in the next step? So is to make use of bind rows function to create rows. So there what we have done is we have used explicit output statements in SAS to create multiple rows from the same row, but we do not have a true equivalent feature in R. So what do we do is, so we take each of the row as many times as required. So here in this case, we need to check each row 3 times. One was whether it was for echo yn is equal to yes, no. And the second one was for yes for LVEF, and the third one was for yes and RVEF. So we are appending the same dataset thrice, but at the same time, we are creating some intermediate variables before appending. So we'll try to discuss this code now in detail. So what are we doing here is we are making use of bind rows function to append 3 datasets. So these 3 lines correspond to three datasets. So what are we doing here is in the first thing, so we are using mutate function. So for that we are using echo, which is our input dataset as input, and then filtering only those rows where echo yn is equal to yes. So which means only these rows where it is equal to yes. And then on this row we are creating CV test CD is equal to LVEF. So on this record, so we are supposed to use the value from LVEF for CV or RES variable. So similarly on the next line, so we are using mutate function for which we are using echo, which is our input dataset, and then filtering only those rows where echo yn is equal to yes. On this second instance, we are creating the entry for RVEF underscore E, and the result for this variable should come from RVEF variable. And finally, so we are checking whether we are using echo dataset and filtering only those rows where echo yn is equal to no. And then we are assigning the test CD is equal to CV all, and then CV ORR yes will be null because this test is not performed at all. And then CV stat we are assigning it as not done on this record. So note that we have not handled the CV stat for LVF and RVF in this particular step. We'll be doing that in a next step. So we will have the same row used thrice, and conditionally we'll get a row if it meets the filter condition or not. And then we'll have the records. So let us take a quick look at CV01 and then see the understand the structure. So here if we see, so we have now created rows for LVEF. So for the first time, so for the first record, so it is like we have used all the rows where echo yn is equal to yes, and then outputted for LVEF, and then we used the rows for RV echo yn is equal to yes and created the entries for RVEFE, and then finally we used the rows where echo yn is equal to no, and then created the test CD CV all, and then conditionally created CV ORR yes and CV stat. So now we will make use of this data set and then create some additional variables. So we are using CV01 and creating CV02 and then adding some additional variables to CV01. So in CVSTRESC, so as the assumption here is that the standard units are equivalent to collected units. So we are directly assigning the value from CVORRES to CVSTRESC. And then for original result, so we were asked to populate it as percentage when original result is not null for LVEF and RVEF E. So here we are checking whether CV test CD is in LVEF or RVEF. So this is kind of equivalent to our in operator, so wherein we can check for the presence of multiple values in a particular variable. So in LVEF or RVEF and at the same time we are checking whether CV or RES is missing or not. So if this is true, so we are assigning the value percentage to that variable. Otherwise we are assigning the text character null string to CV or RESU. Similarly, so what we are doing here is we are assigning the value for CV stat for LVEF and RVEF. So and when original result is equal to missing, so we are assigning the value of not done, so for CV stat. Otherwise we are using the existing value of CV stat because we have assigned CV stat as not done for the records coming from CV all. So now we are supposed to use the previously existing CV stat because here CV stat is being handled only for the parameters LVEF and RVEF, and we are assigning it as not done when CV or RES is equal to missing. And then in the next step we are assigning CV or RESU to CVSTRESU. And then for numeric version of the result, so what we are doing here is we are making use of as numeric function and then converting the CVSTRESC to numeric value. So this is kind of equivalent to our input function with best.in format. So it converts if it is convertible and then stores the value in CVSTRESN. And then we are creating CVDTC here. So this is kind of equivalent to our put and then input. So we are using nested functions here. So in the first step what we are doing is, so we are converting echo DAT to numeric date value using as date function. So and we also need to instruct how the date value is structured in the raw variable. So we are specifying that using format is equal to option, which is using the syntax of D, B and Y, which means D means the day in 1 or 2 digits, and B stands for 3-character month abbreviation and Y is for 4-digit year. So this is similar to our input function with echo dat and then wherein we specify the in format, which we could have used like date 11 in SAS, but here the format has to be referred this way for the way our input data set is structured. And then the created numeric variable is converted back to a character variable, but this time we are converting it into YMD format. So the resulting CVDTC will be numeric, in which the year would be appearing in 4-character wide string, and then followed by a hyphen, followed by 2-digit month, and then 2-digit day here. So this is equivalent to like put of input of echo dat and date 11, and then comma this is YYMMDD 10 dot kind of thing. So now we created CVDTC, and in the next step we are uh, keeping only the required variables and sorting that data set based on project, subject, CVTestCD and CVDTC. So this is how we can replicate the creation of test CDs from variables in findings domains using this R code. So let us take that final step wherein we were comparing our SAS output versus uh, our output in each of the cases. So let us open the output from SAS. So on the left hand side, I have the output dataset that got created from SAS code, and here on the right hand side, I have my output dataset from R code. So let us take a quick look at the things. So there are seven rows, and it is for the same subjects here, same subject, and then we have entry for CV all, followed by 3 rows for CV LVEF, yes, and then followed by 3 rows for RVEF underscore E. So there is not done value on CV all, and also there is a second not done that was for RVEFE on day 3. So this is matching, and then the values are like 67, 65, 68, 60, 67, 65, 68 and 60. This is also matching, and 59 is also matching. CVORESU, we have percentage populated on all those places where original result is populated. So this is also coming nicely or matching. And then we have CVDTC, the first record, as this was not done, so it should be missing. So that is the case in both the places. And then 15th, 17th, 23rd, and again it should be 15th, 17th and 23rd, because these two are the replicates from the same record. So 15th Jan we will have 2 records, one for LVEF and one for RVEF, similarly for other 2 dates as well. So effectively we have replicated the concept. So thank you for watching. Keep learning.